Hello guys, hope you're doing well. In this video I want to show you guys on the 12-volt system for solar how much power we're using for each overclocks. So what I noticed on 12 volts from previous video you probably saw, I started to measuring power usage at 12-volt system and compared to the when you're running on PSU at 110, 120 volt, it's about 10 to 15% probably difference, right? So you could see it is about 10%, so it's pretty good. It's a 90% efficiency on this PSU when you run from the stock PSU, which comes with K0Pro. So that's what I tried first. So it's a pretty good result when you're running on 120 volt system. However, what I want to show you is I'm not going to test every other one on the wall of the power usage, because you probably already have that. There's a bunch of videos on YouTube or tables where on each firmware the wattage at the wall. So what we're trying to calculate here for solar is really figured out how much power it's using on 12-volt system, because we're going to need this information to calculate what size of panels in it and what size of battery needs to have this system work 24 hours on solar on hopefully sunny or partially sunny days. Obviously, if it's a cloud day, we're going to need to create backup emergency system to sustain the battery, either turn down the miner or have it switch to the grid at night, which is a lot cheaper electricity typically in most of the cases if you have different rates for power. So after 12 you could get that emergency power use for if you didn't have enough solar collected through the day. But we're going to calculate based on factors that we use in 90% efficiency on the solar panels, 90% efficiency on the battery. That's typically what rated. Actually, battery rated for 95%, but we'll be very conservative, because what I noticed when I ran this system for a week now, I had quite a few shutdowns because of that. So I had to implement some additional charging or emergency charging, because right now in the winter time there is a lot of shutdowns going on because a lot of clouds or rains, and I don't get that solar consumptions at all. Like I can't collect any power from solar panels. Anyways, that's the other part of my video going to be on that part of the solar. But here we're going to just run the test for all of these overclocks. Okay, that's the T-Swift free overclocks that's available. We're going to put them on test and we're going to run them one by one. So I already started from obviously 200 stock version. It run on 12 volt 86 watts. Very efficient for this miner, for my K0Pro 9, which is a solar miner. Now I have number 8 also. I put it also on solar mining, and it used slightly more on couple of watts more. I don't know why. It's exactly the same fan I use for external fan. They're both 1.2 watts. Very high efficient fans. Every same setup, same way, but one of them uses slightly more power than the other. And I noticed that on my other 7 K0Pros, they're all slightly different. So you could expect your numbers to be slightly different as well. So a couple of watts probably not going to make huge difference, but when you do solar, there is a lot. 3 watts 24 times 24 hours, that's extra 75 watts almost, right? So you have to account for that extra almost 100 watts. Also on the power, when we use that, there's also hardware that uses a little bit of the power from the battery during the night. So like when you're charging, your charge controller also efficiency matters. So using Victron, I think is one of the best solar charge controllers, what I like the most of it, because you could actually get real-time data, especially using Cerbo hardware. Take a look at that. So with the Cerbo, what I'm getting here, let me align this so you could guys see it. All right, so you could see my solar charging. Let me just make it right on the screen here. So you see my PV charger right now. It's 141 watts from 8 panels. So it's very low right now because it's all cloudy. It's gonna rain today. So welcome to sunny California. So if you have the state where you don't have enough sun throughout the year, you can look it up probably online and Google it. But for Sacramento area, it's solar. If we type it in solar for Sacramento days, how many days of solar? What did I put? Alright, so we get like a bunch of different information if you type how many days you get in your area of the solar. So it looks like in Sacramento it's 269 sunny days each year, which is totally great. And especially now in winter, if I set this system working somehow in winter, it's gonna be no problem running through the summer, because I'm gonna have extra power to run some fans, some cooling, hopefully, of the system for summer as well. So I'll have an extra power. I'm not worried about that. So now, and I will need some extra power, obviously, to cool maybe some larger fan to run and stuff like that. So really is certain hours in you get sunshine per day during summertime, which is crazy. That's you almost double that efficiency in the summer. However, we want to be really skeptical and really run the numbers so we can run this system even in winter most of the time on solar. Okay, so let's get to it. It's basically, I have the overclock 200 to 50L I ran. So my machine does not happy with L versions, but and it's did accept it, but it was only 204 gigahash for 250L. It used a lot less power. However, the efficiency very low. It's 1.87 gigahash per watt, just because it doesn't go to 250 gigahash. Now 250 overclocks, you running almost 263 gigahash for my miner, using 117.5 watts. Okay, now I just installed 260L version, right? And I'll show you guys, and I'm gonna go through and install the rest of this and fill out this a table real quick, so you'll have a total value there, and then I'll show you how we calculate the actual panel, how many panels we need, and how big is the battery to run through the night at minimum for running 24/7. Okay, and that's assuming that we're gonna have full sun days even on the winter. So obviously in the summer it's gonna be no issue, and well, with the clouds, we're gonna have to have some support on the power charger, which needs to be automatically switched. So it's all can be created and designed in the same system within Victron. They have a great options to be able to turn on devices with the relay switches and stuff like that. And I'll show you guys that in the later setup. So let's that's basically, we want to start with this table so we calculate how much power we need. I already ran on my previous solar when I installed only one miner, K0Pro 9, on 200 gigahash clocks, which is a stock firmware, and have no problem. We're using one battery, and the 4 panels, I think I had 4 panels. So now I had already upgraded to 8 panels, and today is coming second battery, which I can set it up all this system to run hopefully for 2 miners, all on the solar, you know, on 280 gigahash. I'm not gonna go to the other probably overclocks because it's gonna take a lot of power and will require a lot more cooling, so a lot extra power to use. So let's get to this table, finish this efficiency table, and we'll see where we are with this miner. So the way we do it is I have this camera set up, so I know you could see this green light blinking. That means miner is working, it's mining. On the second screen here, I have the power consumption on the, it's 131 watts on my number 8, but we're working on number 9 right now. So my table is for number 9. It's a little more efficient unit. See, like this running on 280 G firmware, but it's using 132 watts, where my number 9 miner is actually going to use 130 watts on the same firmware. So I choose that one for the table, so I can use that efficient miner first, calculate that, and then we'll account an extra few percent for the second one. So let's get now for 260 version, because my 260L using 113 watts, but only let's check it out. I think my right here, my 238 version is pretty much 263 gigahash. Okay, so wait, let's start it. That's the 250 version. Yeah, so it's been 24 minutes, and you can see I only able to pull 131 gigahash as so far maximum on the 5-minute even rate. So if I let it run for 30 minutes, it needs to be probably 35 minutes. I think my average is going to become around 130. So in this table, I'm going to update my gigahash rate to 130. It's actually started, you could see, at 138, and now it's close to 130. So the efficiency even going to drop down further. So I'm not interested in testing this firmware for way too long, because it's not very efficient even at 130 or 138 rate, and therefore I'm gonna switch to the next one, 260, and so forth. So we're gonna be doing this update of the firmware of this miner, and step by step gonna get to the point where I'm getting to the, after that I'm gonna have to check and make sure that we're doing okay on the pool as well. So our average here on the pool needs to be also justify that hash rate. So the not just only not only on the web GUI or on our device, what we want to make sure is when we look on the 24 average, so it's really require a lot of time to get actual data. But in this video I'm not gonna go through all these little details. What I'm gonna do is keep updating firmware and update the table, so you could guys see the rest of the information pulled up. So we're gonna go to the next one, is gonna be 260 G. So GL basically didn't work for us. We go to G and I update, and I'll confirm the information, and we'll update the table step by step. So I'll post you little videos maybe, and you'll get the full table at the end of this video. Alright, so the miner just started. We are 1 minute 57 seconds, and we already got accepted shares. We have the clocks showed up here all in green, so the temperature is looking great. By the way, this specific miner Ks0Pro I have, I put the Fruition design kit right there. Let's see how I can show you guys. All right, So there is a fruition design. You could see there the front is on the other side, but it's blowing from power and the air comes right through. So on my Miner 9, which is right here, I actually have installed heat sinks on the MOSFETs as well. So it's capable to overclocking all the way to 340. However, I probably not gonna do in this video because I'm gonna need to change the fan after 300. I can do 300L and I can do 300G, 300GL and 300G. So anyways, you could see the miner already start mining. It's 122 watt consumption on 12 volts. So remember, this is only on the 12 volts. So you'll add about 90% efficiency if you want to calculate your PSU here. So roughly the way to get this number, right? So we could put the formula in, this number divide by 90%. 95, see, probably a little bit more than 90%, I think. It's probably 89% efficiency, because if you see 97, yeah, 88%, I would put 88% just to be safe. And so you can update all these numbers here, and you're gonna have what you need on at wall, your efficiency there. So it's roughly 122, and it's gonna be around 138 on at wall. Now it's gonna depend on how good is your efficiency of your PSU, obviously. So if you get upgraded PSU, and the PSU you're gonna need to actually get is 80% power you can use of that PSU. So for example, if this is 140 watt using at the wall, you need at least 138 divided by 0.8. So let's do that simple math. 138 you divide times 8. So yeah, you need 170 watt minimum power supply to run safely these overclocks. Okay, so let's finish with the list. I'm gonna start wait till it's gonna start hashing in full so we could see the numbers, and once we're gonna see the clocks after maybe 10-15 minutes, I'll update the table and we'll go to the next firmware version so we can see how much power we're using and what's the gigahash on each firmware is this miner capable of doing for our solar consumption calculation of the solar use, the battery system and the solar panel system all together. Alright, so I'm gonna pause and I'll update in a few minutes. Alright, so it's been around 50 minutes and we can update our sheet. It's 276 gigahash on 725 clocks, which is using 122 watts. Really great. Pretty good power efficiency. So 276 gigahash, and it's 260G version of overclocks. So I'm really happy with this result as well. Efficiency is slightly better even than 250. Interesting. Obviously the winner is 200 gigahash stack is the most efficient firmware, is basically the stack, obviously, because overclocks always gets more power to use and the heat. So plus the stack, you don't even need to use the fan really much if it's a cool environment. So you can do like at 80, probably 5 watts or something like that. I don't know. Well, let's go to the next one and run it 270L version, and I'll come back in a minute. Alright, so we've been 15 minutes on 270G version. It's 750 overclocks, and we barely making 79 gigahash, so it dropped from 90 to 79. It's probably gonna continue to drop, but not gonna spend more time. I'm gonna go to the next one. Is 270G overclocks, and we'll see how it performs. I'll update here in the sheet. So we have 79 gigahash on 117 watt of the power use on the 12 volts. All right, so let's get to the 270 version, which is also 750 clocks. And let's update it and we'll see what we have. Alright, so we put 270G version. It's just 2 minutes starting to get accepted shares. I also will start adding the temperatures after it runs for 15, 20, 30 minutes. So we'll know what's the temperatures difference on the board. Not gonna have chip's temperature because it's gonna depends on your chip's thermal paste and stuff like that, and the good ventilation. So, but I'm gonna make sure it's not running higher than 50, although I'll just keep an eye. But even 60 is fine temperature, so I don't think any issues with the chip temperatures really that we have with overclocks. It's our board where the MOSFETs are. The temp out is where the MOSFET is, the recording that temperature when it gets really hot. So all right, let's leave it to mine for maybe 30 minutes. We'll get that sheet updated as soon as we have the power. By the way, let's see what's the power consumption already. Okay, it's 100, also 117 watts. Not sure if it did accept the 270G version, because it looks like it's the same wattage that we've got before. So it's hard to tell. Sometimes you update overclock. So the only way we can tell after it starts hashing and to see the hash rate. I have few occasions when I update it and it still was running on the previous clocks. So hopefully this is not the case because the miner restarted. But we'll see. We'll wait and see, and I'll update. If not, then I'll restart it and then I'll update the sheet for you. Alright, so it's been over 30 minutes, 35 minutes on 270G version, and we are pulling on 12 volts. It's actually 13 volts, but it's about the same power consumption. Is about 126 watts. Now what interesting is one chip didn't show up here, but average we're still doing 283 gigahash, 1285 now, and that's 270G version. You can see 750 clocks. My guess is this chip just didn't show up. Let me try to stop and read again. Yeah, it will not probably refresh. I guess it just didn't pop up on the somehow on the software maybe issue, but I would expect it will be a lot lower hash rate here, but it's doing pretty well. The temperature raised a little bit, 3355 with the 1400 RPM fan. So it's not very big fan, but it's usually okay for up to 280 gigahash plus. I didn't increase my speed of the fan, is only 25% internal fans. If I increase that, it will drop significantly, I think. So let's do next. Oh, this actually particular miner, I'll take it back. It doesn't have heat sinks. It's the other one. It's a number 8 that we put the heat sink, I believe. Have to check. Usually it runs a lot cooler. Well, let's check it out. 249. 249 runs on 280. Let's see. Yeah, the temp's about the same. Usually it's a lot cooler when you have heat sinks installed, but regardless, let's get to the next one. 200. We'll actually update the sheet here. We're gonna see we are so we're running on 126 watts, and we're doing 283. Let's be conservative, 283. It's still pretty good efficiency here, 2.25. It's about the same as all other overclocks so far. Obviously a little bit less than the stock, but it's still doing good. So 280L I already tested. It was 70 gigahash at 120 watts, which is not good for me. And lowest actually so far efficiency here in the chart. So the next one, 280G, it actually runs at 290, sometimes a little bit more than 290, 295. I would say like 293 probably, right? So it's about the same efficiency on every overclocks, looks like for me, for this specific miner, K0Pro. All right. So I'm gonna try, I'm gonna go check it out if I do have heat sinks on this one, so I'm not confusing with the other miner, and then I can try possibly to go maybe a couple more 300L, 300 and 320L and 320. I'm not gonna go probably to 340. It's not gonna be efficient on the and I'm gonna use too much power. I'm already for the what I can mine on my solar. It's pretty much at the limit right now with even all upgrades that I did, so I may gonna stay at 280 and possibly even go down to 270 if needs to. The efficiency is really pretty close. It's only 4 watts difference, but I still want to try these versions to see how much more power and what's the efficiency for that, and how much do I need for solar, the battery capacity and all that stuff. So right now I'm good with the 203 amp hours with all the 90% efficiency and power consumption, and the minimum panels, solar panel size based on 200. I need 3,800 kilowatts. Total power, that's for 24 hours rate, so I need to add the column here and divide by, basically what we need to know is the how many panels power we need is for, it's average in 5 hours. So if we divide this by 5, we're gonna get approximate our panel power required. So I'm gonna need about 762 watts only of the panel, and I have 1600. So it's good for one miner, but because I'm doing 2 of these, I'm gonna need 1500 watts of the solar power, which I have 1600, and that's supposed to include the efficiency of a 90% of efficiency on the panel. So should be good for my what I'm calculated, but the truth is, like, it's again that's the clear days. If it's a cloudy day or no sun at all, this number's gonna be completely different. So what we're trying to do is a full sun calculation here that will work throughout the whole entire year, including winter hours, because summer hours we're gonna have a lot more sun that we need. We can use some extra power here, obviously during the summer days that we're gonna need for some cooling, running fans and etc. All right, let's go back and get the rest of this to test it. I'll go check it out, heat sinks, and we'll update the rest of the sheet here. All right, so I had to stop overclocking my number 9 K0Pro because it doesn't have heat sinks. So I'm gonna stay with 280 version. I tried 300L. It's not performing very well. It's 108 gigahash. I didn't want to run it for too long because of the heat sinks not there. So I switched back to 280. It's pretty much where I'm gonna stay for solar mining at 130 watts, I believe, right? So it is, yeah, it's 130 watts on my number 9, and this is the miner number 9. So number 8 miner, however, I do have heat sinks, so I double checked. So this IP249, and let's see what's the temperatures actually we've got so far on the my number 9. Let's refresh, make sure where we at. So we're running at 775 version. That's 280, and that's 280G. It's doing for an hour almost 290, 288. So pretty good overall. It's a good efficiency rate and acceptable for me. I don't want to overclock any further, and I'm gonna stay with the 130 watts consumption. Now remember, this power consumption is it also includes the fan, that it's about 1.5 watts, maybe 1.2 watts. So Just the miner by itself, it's using a little bit less power, but with the fan it's 130 for this specific miner. Now when I did mine on my number 8 K0Pro, right, it's actually using couple 2 watts extra on 280G, and on 300L it's 137 watts, where here was 135. So it's total about 2 watts difference. I don't know why, but this always 2 watts extra on every overclock. So I just put it 300L version overclocks, and I'm gonna let it run for a little bit longer, because surprisingly it started doing pretty well on L with the power consumption 137, which is pretty good for 300 gigahash if it will take. I almost don't want to restart this miner, because if I do, we may not gonna use that overclocks anymore. That's what a lot of time happening if you if it start mining on certain overclocks and then you start changing, you may the second time you restart, it may not gonna mine on the same overclocks, which, I mean, it's possible, but I want to test the rest of the overclocks as well, so it's kind of one of those things. But I want to have it a little extra time, because it's like 297 there now. But even around, if it's hovering around 300 even, it's still pretty good result. I mean, like, look, average 309. What I'm gonna be actually looking for is, it jumps at one point to 320. But more importantly, I want to see if I'm gonna keep this version for a long time to run, and see what's the pool gonna say for that K0Pro number 8. So far it's not been even close to 1 hour, so I can't get the full reports on this specific hash rate over here on the pool. So yeah, it needs 24 hours to be realistic. So it's really gonna be depending how it's gonna perform on the pool after all. But yes, it does works pretty well on the so far on the WebGUI. It's around 300, 309 average. It jumped here at 320 for a little bit. Well, I'll keep it probably for another 15 minutes, see what it's gonna average up to, and we'll keep an eye on it. The temperature looks fine with the heat sinks being applied, you know. It's keeping the MOSFETs cooler, and I don't even run the internal fan. It's only 25%, so I can update 2946 for 300L. Yeah, 2936 and 25% fan speed. Kind of transfer that from the other miner, because I didn't have that record. Yeah, so if you want to pause the video, you can take a look on the power consumption. So what I added here, I added the column. If you're looking for power supply, it's calculated at 80%, so that's what you want to do. I divided by 0.8. That means wherever power usage at the wall, and your power supply needs to be rated higher, so it uses only 80% of capacity, right? So for example, like for mining on these clocks for 130 watts, right, you're gonna use, let's say, 184 watts, 147 watts at the wall. So if it's a 147, obviously on 12 volts I'm only using 130, but if it's 147, your power supply 184. So if you do 184 times 0.8, that means the 80%, you're gonna get 147. That's what your consumption is of this miner. So just to be safe, you should use over a little bit extra power there, like, so 80% is what's recommended, is to the maximum. I mean, if you do like 82%, they're probably not gonna burn the PSU, but I wouldn't recommend to do it. It's always usually better to have extra power than less, because it's gonna overheat your PSU or give an extra heat that you don't need, especially in an environment where you can cool it down. Let's say you in garage where you already have 90-degree temperature, then it's gonna really hurt that power supply. So pay attention to your power wattage here, and yeah, this way you can supply, like I would use 200 version even for this one, just to be safe, you know, just to keep it cooler. So I'm gonna keep on testing now on number 8, because this one is with the heat sinks. Should have just put their heat sinks installed there. This way I know the one that with heat sinks we can update with a little bit extra of the overclocks. So let's go to the next version. We're gonna go to 300 version. I think I ran it before and it was doing 310 or 320, but I want to finish maybe 10 more minutes on this one, and we'll come back and update to 300. And I'll probably not gonna make this video super long on every single one. I'll finish this list, and this way you guys can watch at the end of the video just the full list with all your power needs and your power for your power supply. So this column as well, it will help you just to decide what power supply you're gonna need to use. And over here, this way you can pause the video and take a look on these numbers, compare to what are you planning to use for your overclocks, if you are. Now this my testing is totally for solar usage, because we're gonna calculate and see where we're gonna stop. For my solar probably purposes, I'm gonna be stopping at 280, so I don't use extra power for fans and anything like that for now. If I get more sun and I'll see that I can use extra power, then we'll see if we can continue overclocking. All right, but for now I just want to make sure it does take the rest of the overclocks or not. So that's gonna be after this, so I'll keep updating that chart, and we'll see in a little bit. Alright guys, so I just finished with the last firmware, which is 340G, and right now currently it's still running on that version. I'm gonna switch it back, but just want you to see real time this video on the camera right here. So my miner here is doing 168 roughly watt, right? 168. This is the one, the number 8 we're doing for 340 version. All right, so it's running normally, and let's take a look on the so this is the Iceriver monitor tool, so that's showing the temperature, so they'll look pretty good, okay to me. So let's take a look at the final chart. So what I did on this table, I updated all the power rating for every single firmware what we have right now. So the last one is actually 167. Let's take a look one more time so we can get it correctly. 168. All right, so it's after mining for a while, it gets updated number, so that's great. All right, so everything here from 270 firmware all the way on this miner, I took it all the way down to 340G version. And surprisingly, this is the only miner I have. It takes the L version after 280 firmware. So it doesn't take 280L, but it runs nicely and smooth on 300L, 320L, and 340L, which gives me a lot better efficiency right here in this graph. In this column is the efficiency. So you can see all the power consumption on 12-volt system. So just don't confuse that. That's on a 12. This is your power on if you're gonna run it on 120 volt plus minus, because of your PSU efficiency gonna matter here. And also recommended minimum power supply PSU right here. So if your power supply, if you're trying to run 280 version, I wouldn't probably use 200 minimum watts for that purpose, so you don't overheat that. And then if you go all the way to 340, you need to find probably 250 or at least 240. You know, I don't know if they have that kind of power supply. Anyways, so that's for you the chart for this power supply. Now I have this also temperatures here and the internal fans percentage that I ran. So some of them I had to run lower because the temperature were okay. Some I had to run all of this, the last 3 on 100% because I didn't want it to or overheat anything. And by the way, I only running, surprisingly, this miner is okay on with the fan. So I have fruition design on one side, you could see on the video, right? It's from the back, but if you look at that, we have fruition design just right here, and this fan's blowing only one way. I don't have a second part attached here. It's just blowing right through it, and it's only 1400 RPM fan, so it's not powerful fan that I used before. And surprisingly, this miner works pretty nicely on all of the version with the heat sinks obviously installed. I wouldn't try that without the heat sinks because then you would damage your MOSFETs most likely, but with the heat sinks it took pretty nicely. It's one of the nicest miner, I think, but it's problematic on all of this 250 to 280 firmware. I have to restart almost 2-3 times before it would take firmware. Otherwise it will get stuck, and then I'll have to turn the power off, turn the power on, because it will completely be unreachable. So this is one of the interesting K0Pro. You may have that similar experience with yours, and this information may be helpful for you, because if you see you cannot reach on the web GUI, you could just disconnect power, wait 30 seconds, connect it back, and see if the green light needs to blink. If the green light stops not blinking, or all the lights out, it will not gonna show up on the web GUI, and it will not mine, so you will have to restart again. For a few occasions I had to restart this miner almost 4 times until it took, but eventually it would take every single of this firmware, but I didn't test it at that time. I was just skipped it because I have tested on the second one. All of this without the heatsink, so for you just to compare. And this performs a little better, so it's about 2 watts less on every clock. So it's a little higher efficient miner, but it will not take any of the L version, none of them. You know, all the L's were just mining a lot less. You could see that in the gray section there, right? So I was able even to put 300L, but I wouldn't recommend without heatsink, since I didn't have heatsinks. I didn't want to run it. I just ran for like 30 minutes, 40 minutes just to see the hash rate, and that's it. And I switched back to 280, which I'm currently running on solar, right? So if you guys want some information from this sheet, you can pause, look at this from 200 to 280, and then everything past here from 280 to 300. Very similar data for clocks, but I mean for the power, only a couple watts difference, so nothing major there. Obviously, the this guy took a lot better of the hash rates compared to my other one. For some reason, this didn't like any of the L version, except just 250L actually was running even lower. But all of the G version was fine, no problem, and currently running on 280 for 291, 295 gigahash easily, almost 300, you know. So let's do review for solar. What I do for solar now. So my orange line here is what I'm gonna use, 280, because I want to be I have 4 panels for each. So I have 8 panels, right? 8 200-watt panels solar. So this table calculates for me how many panels I need to run this smoothly. Obviously, when we have sunny days, at least 80% of the sun, right? like if it's rainy days, we have to have some kind of emergency backup, and I'll show you guys on my installation video for the solar system. This way you could see what I've done for that, and it's programmable, so in case there's no rainy for a week, let's say, especially like in the winter time here in Sacramento, we have rain sometimes for a whole entire week, no sun, and we'll need support. Like today, I only was able to collect let's see right here, consumption from solar, only 1 kilowatt hour of energy, and I used 4.7 kilowatt already and 3.8 from battery. So my battery is almost dying. It's 18% left, and it's totally charged from yesterday installation. You'll see guys on that video, but it was 2 batteries totally charged. I was supposed to have total of close to 5,000 watt hour battery, 5 kilowatt hour, and my system already used 4.7 and only 1 kilowatt solar support, so it will be not enough to obviously to run this 24/7. So for those emergency days, like we have few days in Sacramento, probably like, you know, couple months maybe in the year, and those gonna be backup power. We're gonna track separately. I want to track I connected the power meter that I'm gonna track. I zero it out, and I'm gonna see how much actually power I did to support charging, like let's say in this winter months until sun comes up totally. You know, when it's sunny, it will be pretty much like 110, 115 degree here, and I'm probably gonna have enough power, even extra power, to use for something else. Anyway, so that's for the solar calculations here. I hope that table will help you guys to decide like what type of solar to install. So all this testing I did just for that purpose, and obviously for the rest of the stuff, just so you guys could see the numbers. Maybe it's helpful, like what actually you're doing, how much power you're using for 24 hours, like a day, and then how many ampere hours a day and stuff like that. So this all information is to calculate your solar loads and your solar requirement. So I'm really figured out the battery size. So there is a minimum battery size that I need here in this column, and this minimum solar panel size for the system. So I need at least 774 watts for this. I can do probably 300L for this specific miner, but I don't want to overload. I want to have enough power to run smoothly 24/7, so we completely green on this system. So I hope this makes sense, and that's our goal. So we'll be running 280 version for now, until if I have a couple more panels, I will need like a couple panels, one for this miner, one for this miner, and potentially larger battery, which I have right now. So it's calculated 200 amp hour I need battery here, and 206 and 203. So I'm already slightly short. I only have 400 amp. My 100 amp battery failed, and I'm not supposed to connect parallel. What I figured out, that 200 and 100, so you have to connect the same. If you use in parallel, it's not a very desired connection for the battery, but if you do that, you need to use exactly same amp hours batteries and same cells battery, hopefully, just so they match the internal resistance. So this way they will not drain, one will not drain faster than the other. So let's take a look on the just show you real quick my screenshots. So what I did, so you could see, okay, so this is the 320G, 158 watts, so that's what's running 320, and then 320L version. You can't even tell the difference because it's the same clocks, but that's just using slightly less power, 151 watt versus 158 watts, right? And then this one is 340L. Yeah, 340L, which ran pretty nicely actually for me. If I have enough power, I could run 340L because it performed beautifully too. and it uses 168. Now 168 is for 340G. I'm sorry, yeah, so this is 340L, and it uses 164 watts. So efficiency wise, if we look what my miner here is, probably for me best efficiency is 300L, and 280G is not that far apart and pretty much probably stable, more stable. So that's how you would determine what are you better off with what efficiency, and between efficiency and having higher risk of the heating, or you actually want to have more hash rate using higher overclocks. Alright, so that's it for this video. It came up pretty long. Hopefully you just scroll down to the end and see the tables if it's helpful. And we'll see you on the next one for the for this 2K0 solar installation system. Alright, thank you for watching.